All right, let's get into it. Today, we're digging into the world of modern graphics, looking at two really powerful APIs, OpenGL and Vulkan. They both help create the incredible visuals you see in games and apps every day, but, and this is the important part, they go about it in completely different ways. So which one is the right tool for the job? Let's figure that out. I mean, seriously, think about it for a second. You've got this amazing piece of hardware just sitting in your device, right? It can render whole universes in the blink of an eye. But your favorite game can't just yell at it and tell it what to do. There's got to be a translator, some kind of common ground. And that right there is where graphics APIs come in. So an API, it's basically the bridge that lets your software talk to your hardware. It gives developers a rulebook and a set of tools so they don't have to write custom code for every single different GPU out there. It's the essential middleman. And honestly, modern graphics just wouldn't be possible without it. Okay, so here's our game plan. We're going to kick things off with the big picture difference between these two. Then we'll pop the hood and look at the tech. After that, we'll see how it all plays out with some real-world examples. And finally, we'll get to the big question, how do you choose the right tool for what you're building? You know, the best way to wrap your head around OpenGL versus Vulkan is to think about their core philosophies. It really boils down to that classic trade-off. Do you want to get up and running fast, or do you need absolute, total control over everything? And I love this analogy from Mark Kilgard over at NVIDIA. The original OpenGL was kind of like a pre-built toy car. You just took it out of the box, and bam, you could have fun with it right away. Super simple. Modern OpenGL, though, it's more like a Lego kit. It gives you all these powerful, standard pieces, and you get to put them together to build something really cool yourself. So if OpenGL is the Lego kit with all the perfectly formed bricks, then Vulkan is like a Pinewood Derby kit. You get a block of wood, some wheels, and a couple of axles. That's it. It's totally on you to carve it, to get the weight just right, to make sure everything is perfectly aligned, to build the fastest car you possibly can. You have all the control, but you also have all the responsibility. So that's the heart of it, right? It's all about this trade-off. OpenGL gives you a higher level of abstraction. The driver is doing a ton of heavy lifting for you in the background, managing memory and stuff to make your life easier. Vulkan just rips all that away and gives you direct, low-level access. That means way more power, but you guessed it, a whole lot more work. So what does all that control and abstraction actually look like when the rubber meets the road? Let's go under the hood and really compare the nitty-gritty technical details. This table just lays it all out, doesn't it? With OpenGL, you're mostly dealing with a single global state machine, and it's pretty much single-threaded. Vulkan, on the other hand, was built from the ground up for the multi-core world we live in now. It's asynchronous, it's multi-threaded, and it uses these pre-compiled state objects, which can just slash your CPU overhead. See, in OpenGL, the driver creates what some people call a synchronous illusion. It feels like your commands are just happening one after the other, nice and neat. But behind the curtain, the driver is scrambling to manage the messy, asynchronous reality of how a GPU actually works. With Vulkan, that curtain is gone. You are in charge of managing everything, the dependencies, the timing, the memory. It's way more complex, but it's also a much more honest reflection of the hardware. Okay, all this technical talk is great, but how does this choice actually impact real projects? Let's look at two wildly different examples, a mission-critical system for a fighter jet and an indie game. So first up, imagine you're building the cockpit display for a fighter jet. This thing was originally prototyped using Vulkan, but it needs to be safety certified. We're talking about a situation where every single frame counts. You absolutely cannot have any unexpected stutters or crashes. It has to be rock solid and predictable. Now check this out. When the team ported the application from Vulkan over to a safety-certified version of OpenGL, look at that difference in development time. The OpenGL version took about 10 days. The original Vulkan prototype, around 35 days. We're talking more than 3 times faster to develop an OpenGL. And this chart really shows you why. The complexity is just on another level. The Vulkan version needed about 4,500 lines of code. The OpenGL version, only 1,500. For this kind of safety-critical job, the sheer amount of code and complexity in Vulkan was a huge problem, while OpenGL gave them a much cleaner path to a certified product. Okay, now let's jump to a completely different universe. This is a quote from an indie game developer. For them, the goal isn't safety certification, it's about getting their game built and out the door to as many players as they possibly can. And for this staff, the choice was a total no-brainer. OpenGL ES runs on pretty much everything, including older devices that don't even support Vulkan. It's powerful enough to do what they need, and because it's the foundation for WebGL, it's not going anywhere. The raw performance of Vulkan just wasn't worth giving up that massive compatibility and, frankly, the easier development process. So this brings us right to the big question. Which API should you actually pick? Is all that extra pain and effort in Vulkan really worth it? And as we've seen, the answer, as always, is it depends entirely on what you're trying to build. Let's look at where Vulkan is an absolute rock star. It really starts to shine when your application is being held back by the CPU, not the GPU. If you can fire up multiple CPU cores to get rendering commands ready in parallel, Vulkan's multi-threaded design is going to give you a massive performance kick that OpenGL just can't touch. It's also perfect for fixed hardware, like a game console. When you know the exact chip you're programming for, you can tune every little piece of your Vulkan renderer to squeeze out every last drop of performance. That's a lot harder to do when an OpenGL driver is making a bunch of those decisions for you. And this takes us right back to that fighter jet cockpit, right? If you need predictable, buttery, smooth performance with zero unexpected stutters from the driver, Vulkan's explicit control over memory and timing is a huge, huge advantage. You are in complete command. But, and this is a really big but, Vulkan is not a silver bullet. If you need to support older devices, it might not be an option. If your app is already maxing out the GPU, Vulkan won't magically make it faster. And if your code is single-threaded, you probably won't see much of a benefit. Oh, and most importantly, if you can just use a game engine like Unreal or Unity, they do all the hard work for you, so you get the performance without the headache. So at the end of the day, this isn't about which API is better. It's about picking the right tool from the toolbox for your specific project. Do you need the simple, get-it-done fun of the pre-built car, the creative flexibility of the Lego kit, or do you need the raw, ultimate control you get from that block of wood? The right tool depends entirely on the masterpiece you want to build.